Okay, so toString, we've seen there, and as I mentioned earlier, toString is what println calls. So once you define a good toString, then when you print that object, the object will print nicely. Okay, equals. So, in Java we have equals used for assignment. We have the equals equals, which is really equals. And now you have this equals method. Okay, so lots of 3 different concepts with the term equals in them. One of them is assignment, obviously. So then the question is, what is the difference between equals equals and this equals method? Okay, so that's the intention at least. That are the addresses the same, or are the contents the same? Okay. So if I have a Cartesian point, okay, and I say P2 is assigned P1, right? So P2 has the address 8 in it, and P1 has the address 8 in it. So P1 and P2 both have the same addresses stored in those variables. And I say P2 equals P1, I'll get what? Okay? Because they both point to the same object. That's equals. Okay? If I say P1 is a new Cartesian point 200, 200, I say P2 is a new Cartesian point also 200, 200. Okay? And I say P2 equals P1. The answer is 8 is not equal to 48. False. Okay? So that's exactly what James said. Okay? They pointed to different objects. Okay. Now my picture is not wrong. So I said S1, please, I'm telling Java, even though it's the same constant, allocate a new object. Please, please, please. Okay, so it will allocate a new object, even though it's got the same string in it. So I have Jodo and Jodo both allocated twice. String S2 is pointing to the one Jodo, and string S1 is pointing to another Jodo. Okay? And if I say S1 equals S2, now I get false. Yeah.
If you use one new string call and assign the other just to string without calling new string, will they both point to the same location?
No, they point to different locations.
So each of those is indicating something different than the standard string location?
See, what happens is this. The compiler, when it sees, so, when you put the number 5, the number 7, the string Jodo, okay, the compiler has to go and make sure that these values, and you say if some variable is assigned these constants. The compiler has to go and create some memory area called the literal pool, okay, in which it goes and loads these constants. At runtime, from that location, the variable is assigned. It's not as if the variable has this value, built into it. It's got to be loaded at runtime. Okay. So what Java used to do when it created the literal pool was, when the compiler writer was lazy, every time he saw Jodo, he went and created a new object in the literal pool. Okay, which made no sense. When I studied compilers, that's what we learned we shouldn't be doing. Okay, the literal pool always goes and makes sure that the number 5 is loaded only once, the number 7 is loaded only once. In particular, the number 0, which is used a lot, is loaded only once, or number 1. Okay, and finally, the compiler writers, got their act together and decided that they will create only one Jodo for each occurrence of Jodo. Okay, because you didn't say new. Here you're saying, so there's one area that's allocated by the compiler writer in the literal pool. One is being done by the programmer. So they should be different. Okay? So I believe, I don't know what happens exactly, but that's what I would imagine is happening. Okay? And if I say now S1 equals S2, what will I get? Okay? That all works very well. Okay, I got string history 1 equals the new string history. String history 2 equals, as a sign, the new string history. This will return false. Okay, they are two different objects. Equals true or false? So they are the same contents, right? The contents is null, nothing. They're empty histories. Right? James, you're saying something?
Yes, I said the concept.
But we know exactly what it is. It's a new string history, which is empty. True? Well, memory location it looks at for equals equals. I mean, how is this different from the string example? Right? Same thing. That they're in different locations, but the contents are same. Here the contents are same. There are no contents, it's an empty string history. Two empty string histories are equal to each other. So you would want equals to return, but it won't. For null? Well, you know, if I go back to the string example and I said new string, null string, with nothing in it, new string, null string, it'll actually still return true for equals. I mean, if I added to both string histories an element Jodo and I said equals, again it'll return false. Well, what do you think is happening?
You requested each one of them to be assigned to a new string history, something completely unique and different. So you can ask them to be either equal to each other. It's not reading the same value now.
No, but how's that different from the string example? I say new string, null string, new string, null string. I'll just make it more isomorphic to this.
Well, I'm not entirely sure what the value equals method does in the object class. When I go through and override the value equals method, I would have it check through the string history to see the individual elements are the same. I imagine the object class is looking at about what the same as the equals method, and the example as well. You can't interpret what exactly all the objects in Java are, how they may be compared.
Preeti?
No, I was going to suggest that maybe the string history for individually calling new string methods. New string objects. So.
No, we saw what string history was doing. Okay, Collins is exactly right. Equals is something that is overridden, can be overridden. We know in the case of string history, we are getting the equals defined in class object. We never define an equals there. In the case of string, we didn't define string. Okay? And so, and the equals, so let's go and try to figure out why this is not working. So we are getting the equals method in object, class object. Now, can the equals method in class object access the instance variables? For these to be, to make sure that the two histories are equal, we have to go through the histories and see if each element is the same or not, right? That means we have to go and access that array that we defined in our subclass. That array is not accessed, and the size field that we defined. Those two variables are not visible in class object, and class object doesn't even know, even if they were visible, what to do with those variables. It's just two variables. So when equals returns a correct value, it's typically because some class overrode the equals method. And this must mean that the string class overrode the equals method from object. And if we want equals to work right, we must do the same. Okay? Okay? So we have an equals method defined in class object with this signature. Okay? And what do you think it does? So it returns true if they are, I mean, you're recursive, it can't call equals again, right? So it does what? I mean, you don't know what it does, but you don't know exactly what it does, but from the behavior that I gave to you, what could it do? If you were to define an equals method in class object, what would you do? Actually, Collins gave the answer away earlier. What must equals be doing? Okay, returns whether if this object is equal to the other object. Okay, and since the two addresses were different, okay, this is being very conservative, and it's saying when in doubt, say no. So when they are equal, then we know they're also equals. So it's, when it returns true, it will be true. Otherwise, it says, it just doesn't want to say true when the answer is false. Okay? Now I call this method polymorphic. And you all heard the word polymorphic. Not you all, but many of you have heard the term polymorphic before. So when I say a method is polymorphic, what do you think I mean? You can? So what's an element of a method? Parameters. So a method that has parameters that you can change. A method with multiple parameters, but this method has only one parameter. What does the word polymorphism mean to you in English? Many forms. So what could it mean here? Yeah, Preeti?
Maybe a method that can change, that displays different behaviors for different species. So.
That has, okay, from the English word, that seems to indicate what it is, that it does different things for different, okay. That's a very good guess based on the English meaning, but not quite, actually, just the opposite. Yeah?
One method call that, depending on which class you're applying it to, it will return different.
So, a method that does different things based on what class it's being called on. So, in fact, the word, that could also be considered polymorphism. That's sort of called inheritance subclass polymorphism. But it's basically a method that can work. The intuition is right, that it can work for multiple classes. Anybody else want to guess here? It's kind of related to what Colin's saying, but also in some ways the opposite of what he said. How many of you have seen the word polymorphism in your previous class? So, yeah. Okay. This argument can be a Cartesian point, a polar point, a string history. Okay? So you have one method whose actual parameters can actually be instances of different classes, can be different types. Okay? Now it's not consistent with this. It's not as if it does different things. It does. It could do different things based on what it does, but there's only one method, and it doesn't go and check which type it is. Okay? If it does different things, that happens because of the method it's calling. Okay? So you just define this one method for multiple classes, multiple types, and that's what we'll call a polymorphic method. Okay? And we see that equals is a polymorphic method, and because it doesn't do multiple things, it's not working very well for us. It does only one thing for all objects, and that's why two string histories that are really equals are called not equals by this method. Okay? And a good polymorphic method would do the right thing and yet take arguments of different types. Okay? But the definition is very technical, that it's a method that goes and takes arguments of different types. Now, the class on which the object on which a method is called can be considered an implicit parameter. You can think of that as another parameter, the object of which is being called, and then what Collins was saying kind of applies. Okay, but for now we'll just look at the explicit parameters and say that can the explicit parameters be of different types. Okay, so let's go and figure out, so ISA and polymorphism are related to each other. So when I go in, this is another polymorphic method, print line. Okay, you can send to it any object, Cartesian point, whatever. Okay, it does only one thing, but this is a good polymorphic method because it calls this toString method, and hopefully the toString method returns the right value. So you will get different values for different objects, even though you've written one piece of code for all objects. Okay, so because it calls toString, which can return different values, it will do different things, but you can pass it to it a Cartesian point, a polar point, a string history. So again, polymorphic method actual parameters of methods can be of different types, instances of different classes. Okay, and you can write polymorphic methods because of the ISA relationship, that you declare the parameter to be of a certain type, and you can pass to that. And the actual parameter can be any type that is the type of the actual parameter. Okay, so because we have ISA rules, because we had all these assignment rules, rules based on ISA relationship, we can define polymorphic methods. Okay, and a lot of people confuse overloading with polymorphism. Okay, there are textbooks that will call overloading as polymorphism. So here you see both overloaded and polymorphic methods. Which are the polymorphic methods and which are the overloaded methods? The print line double, is that polymorphic? Only take doubles. Print line int. So print line object and overloaded. It's polymorphic because it can take various types. Plus, there's other print lines too. So it's both an overloaded method and a polymorphic. Okay. And sometimes you can replace one polymorphic method with multiple overloaded methods. And it's always a good idea to do overloading as long as you get the same result, or polymorphism because you write the code only once. And my print method here for string history, which is sort of like the toString method I wrote earlier, is now an example of a polymorphic method because it can take string history, string database, STRINGSET. Okay? For these reasons. Oh, I meant to say STRINGSET here. Okay. So the STRINGSET users say that we want a proper equals. This equals is not doing it for them. Okay? So where should I put the equals method that I'm going to write? Which class should I add it to? So the STRINGSET guys are the ones who are, the squeaky wheels. They're the ones who complain a lot. So they said, hey, we tried equals, it doesn't work right. Give us the proper equals. So you're not the programmer. You could, of course, add the equals method in a STRINGSET, but where else could you add it to? Or, and would you compromise in any way by going to the higher subclasses? Equals semantics doesn't depend on it being a database or a set. It depends on the contents and size, which are available in string history, so that's where we are. Okay, again, just like with the toString method, with the equals method, that's where we add. Okay. Now, when you're going to override the method, you have choices. when you're going to add a new equals, you have two choices. You could add equals with object as an parameter as the argument type, or you could add equals with string history as the argument type. We're going to add it in the string history. Okay. If you add it in string history, either way, we can call equals with string database or string set also. Okay. So now I have a little design choice. I could override the equals I inherit from object, or I could overload the equals I got from object. You guys have an opinion as to which way to go? Okay. If I overload it, I can use it for so if you want to go, that's interesting. I may want to check whether the string history is equal to another string history, or whether the string history is equal to a Cartesian point. I should be able to do both, right? And you seem to be indicating that with this, for string history, this equals is called, and for other objects, that equals is called. Right? Yeah, that's a very good answer, actually. We don't know what our equals is going to do. So we'll have to figure, we don't know what this equals is going to do. But depending on how that equals is written, maybe that answer is right. Okay, so let's go, I think in the next slide. So first, should we define a string history as it is then available to and overridable by all subclasses. And if you are overriding a method, then the signature has to be identical. You can't go and say string history. Okay, so this is overloading. Okay, so let us go, and we really don't have time. That didn't turn out to be too bad. Here's a bad way to do things. Okay. Okay, I didn't check this, sir. I didn't check for the null value. Is null an instance of string history? By the way, I'm being bad. I'm using class names, but I'm using class names deliberately here because you may encounter code like this. Okay, and let's just address one point before we leave. So I've got to check for null here. Is that redundant? Is null an instance of string history? Can I assign to a variable that's declared to be string history the value null? So it's kind of an instance. From Java's purposes, it is instance. I mean, it's nothing. It's null is kind of one of these things that you can't figure out what it's a borderline object. So I want to make sure that if it's null, I return false. Okay, so that here I'm being good. But I'm actually checking if it's an instance of a string history rather than string history. I'm being bad. Okay? But because I'm being, and I'm showing you this code only because tomorrow you may have to go and look at other people's code and I want you to show you certain features. Notice what I do here. I check if my size, I don't even call methods. If my size is equal to other string history size, I can actually access the instance variable. Even though size is not declared to be a public field, I can access size because where is size? Which class is size declared in? String history, right? Where is this method defined? In string history. We know that other object is the string history. So because the other object is us, we can be actually access the instance variables directly. If for some reason equals needs access to instance variables in addition to the methods, then you could define your equals this way. In our case, it doesn't. Okay, so I just want you to show you this feature that variables can be accessed in the class. Okay, as long as you do something like this. So we'll carry on from here next time. So if you want to do that, we do, and the reason is that we use a class-based equals method. So you can't use it to compare arbitrary implementations of string history. Okay, let's start. Questions?
We
Okay, yeah.
create classes and send other classes. We add a note like we do from one more public method. We actually find a new interface that that's basically have that one method. So for like you said before, you still have to have the interface for every single public method that we create. And then if we have a class that implements a super class that
A class doesn't implement a superclass. Class extends.
That doesn't have any public methods, you still have to define an interface for it.
Okay, so there's a class like STRINGSET that extends the string database, and the STRINGSET doesn't add any new methods. Should you define a new interface for STRINGSET?
Sure.
Did we do that in class, in the lectures? Do you remember? So STRINGSET implemented the same interface as superclass. But there's no harm. In fact, I would encourage you to create a special interface called STRINGSET, which just extends that interface, the string database interface. Why would that be good practice? Why would that be okay practice at least? So that you could maybe add in a method later. You know, when you have an if statement and you have a then part and you have an else part, if the then part has only one statement in it, do you need curly braces? You don't. Right? Around the statement. If you have two statements, you need curly braces. So, but it's good practice. Every company you will go to will say, please put curly braces there, because then you can add another method. Okay? Add another statement. So, but you don't have to. Questions?
When we're including the subclass or stateful class to for the included section, you want us to create a new method just to stand for the specialized point user name who is say class, or do you want us to kind of amalgamate that with our or the other method that already stands for everything that needs
So, I don't know. I don't know what I said there. But from what I remember, the purpose of the assignment is to take the original class and create a new class that does different things. And I don't believe the intention is to change the methods. I mean, you're still scanning a string.
Right.
And you're still showing the same thing. You're just doing things differently. Right? You're creating specialized token classes in this assignment.
Okay.
So it doesn't matter. The interface doesn't change.
Right, the interface doesn't change, but in our subclass, should we create a new method, another method just to scan for the user name, or
You're scanning the same thing, right? You're scanning a string, and you're creating tokens out of that. So if the method, are you saying, I mean, you have to write new code there, and you'll probably have to re-implement some methods. I think I say in the assignment that the reusability is very limited at this point. But the public method signature will not change, but the implementation probably will change because you're doing different things. So I think to meet the constraint of the assignment, you'll probably have to do this. But, you know, like I say, whenever somebody asks me, is this what you're asking in the assignment? I always say, I don't know. I really don't remember. So the right question to say is that you know, you say this in the assignment. I'm confused about what that really means. So clarify. And then I'll look at, you know, then I'll try to interpret that. Because I really, you know, from what I remember, I was just asking you to re-implement the methods. And try to reuse some code if possible. And if not possible, that's okay. We'll do the scanner again later in a much more modular fashion, where you'll be able to reuse much more code. Okay? Other things? Ask in class, because I'm going to CC to the whole class. I don't want to repeat things, right? So ask right now, because if you have a question, you know, there's 5 other people who are too shy to ask that question. So it's good to ask questions.
I'm kind of confused by, like, the aligned movable cat history.
Sorry, say that a little clearer.
Like, under the header aligned movable cat history, you're saying
Aligned, okay, yeah?
we want to make sure that they're all left aligned,
Yeah.
and then you're saying that we're going to add elements that change the X coordinate, so are they left aligned or are they change?
How do you left align something?
They're all doing that.
So you'll have to change them to left align, right? If something doesn't want to be left aligned, you're going to make it left align.
Okay, so, like, if we add a new element to chat history that has a different X coordinate, everything else changes too?
You have to make them left aligned, that's up to you. As long as they are, you'll have to so you'll either go and take the new element and align it to the previous element, or you align the previous elements to the new elements. Okay? And I think I'm hinting there that the new element, it seems, if you already have 10 elements added, and you've got a new element that's got a different x coordinate, it seems better to go and change the x coordinate of that new element rather than the previous elements to align them.
I just want to more changing the x element.
X coordinate, sorry?
X coordinate basically just going to align them.
How do you align something?
Well, I mean, I don't see the point of allowing the user or something to change the x coordinate when we're supposed to modify it.
The user is going to give you some label, right?
Yeah.
It's got an x value. The user can't say, take out the x value. Okay, so the user will probably not even specify the value, probably be 0. Okay, well, the user decides to make it, 150, then you just ignore that x value, basically. Okay, other thing? So a lot of you were wanting this to happen in the previous assignment. I got a lot of emails, why can't we just align them in the history class, in the collection class, and why do we have to keep the label coordinates? Anybody have an idea why I was, why I did it that way? That I forced you to first create a class that doesn't align things, and then I'm asking you to create a class that does align things? Why not? Why shouldn't your first class have aligned things, and, which is what many of you wanted to do, because you didn't want the user to align things, you wanted the class to do it. Yeah. But now I'm asking you to make them the same. So why is it that I postponed this capability? Yeah.
Because it allows more flexibility in case you do want them not to be aligned.
In case you do want them not to be aligned? Yeah.
So we keep the narrative, so they can try that line.
So you've got 3 kinds of collection classes now. And right now you cannot use inheritance. Okay, you don't know enough to use inheritance in collection classes, so don't even try. Okay? But later, when we study generics, you'll be able to use inheritance, and then, the marching knights are aligned in some ways, and marching knights have some methods that the chat history also has, so you'd like the 2 classes to share code. So let's go, and we allow more flexibility, we allow the more general case, and then we allow the more special case. And when we allow the more general case, there'll be more sharing of code. Okay. Other things? Wednesday. Is that the normal date?
Hopefully before then, but that's when we try to have.
Obviously, they want to submit on Wednesday, so it should be just have a day before that. All of us are trying to meet deadlines, including you. So I sometimes barely am able to complete my lecture before coming. So, but we try to do that before you submit at least. Okay. But of course, when you write your assignment or when you prepare for your exams, don't write to the rubric. You should be able to, do it without that and later check that. Similarly, a lot of you are sending me mail, where are the old exams? At least one of you has sent the message. And again, it's just, I have to do one more action, which I haven't had time to do. But don't study for the exam that I post, because I may ask something different, okay, depending on what I covered in class and what I'm thinking that time, the exam depends on that. So it's just a hint as to what might happen. It's not a model.
Also, the rubrics are very closely based on the assignment description, so conforming to the assignment description means they'll conform to the rubric. It's not like we make it up differently. So.
But still, yeah. Okay. Anything else? So we were looking at the equals method. Okay, and we're going to use this equals method to uncover many, many concepts in Java. So here's how the equals method was motivated. Our string set users said, hey, we want an equals method to see whether 2 sets are same, have the same contents. And string set inherits from string database, and a string database inherits from a string history. So we said, well, if you're going to add an equals, the equals is going to look at the contents and the contents of this, are represented the same in all three classes. So let's just add equals in a string history, so that even the string history users can use it, the string database users can use it, and of course the string set users can use it. Okay? So that was a goal, and we of course are given an equals from class object, but that equals is very conservative. So if two objects are equal, it says yes. If they are, definitely says yes, but it can say no when they're equals. Just because it doesn't look at the content, it says if the two references are the same, I'll say yes. Otherwise, I'm just going to say no because I don't know, I can't see look at the contents. Okay, the contents depend on instance variables that are declared not in class object, but in the subclasses, and a superclass class cannot look at the variables in the subclass. Okay, so the question was override in which class, and we said, and what should be the signature of the overridden method, and we saw that we were going to do that in a string history, and we had two choices for the signature. We could use the same signature as in class object, in which case we are overriding, we are hiding the method in class object. Or we could say that, we are only interested in checking if another string history is the same as us. Okay, if it's something else, we'll just use class objects equals, and that class object will say no if it's not a string history. So that's exactly what we want. Okay, so we could either override the method or overload it. Okay, we overload it when we have the same name but have different arguments. Okay, and we actually then kind of wrote this method where we didn't specify the whole details, and what we first checked was, since we're overriding, we have to take care of all cases, even when the other object is not a string history. So the very first thing we checked was if it is a string history. If it's not a string history, we said we know it's not equals. Okay? Otherwise, we looked at each element of the string history and compared it with the corresponding element in the other string history, and if any one of these elements was not same, we said false. Okay? This is what we came up in class. And just to confuse you then, I showed you code that is both better and worse than the previous code in some senses. So here this code not only checks if the other object is an instance of a string history, is instance of the right type, it also checks if the other object is null. Okay? And null's a funny thing. Is null an instance of string history? Yeah. It is, in the sense that I can assign null to any variable that's declared to be a string history. Okay, so null is an instance of anything. Okay, and it's kind of why is that? Is that counterintuitive to somebody? Yeah. It's nothing. I can't do element at. Okay, and that's why you get null pointer exceptions. Java says, fine, I'll allow it, and then at runtime you get null pointer exceptions. So because it's so lax about its rules, because it says, yeah, null is everything or null is nothing, so nothing can be assigned to anything, it's kind of, it's counterintuitive. So to me, I have to know that null is, the fact that you can assign null to a variable is something you have to know. And when a variable is first created, it's got nothing in it, so they have to allow null to be assigned. But when you do assign null to a variable, it's dangerous. Okay, and that's why at compile time, often Java compiler will tell you, hey, this variable has not been initialized, so beware. At runtime, you'll get errors. Okay, so that's where I'm good. Okay, I've checked for equals null, and now I know that I can cover that case. I won't get some null pointer exception. I would get a null pointer exception in the previous code. Okay, so here's where I'm being bad. I told you, classes are meant to be instantiated. Classes are not meant to be types of variables or types you ever use. Okay, always use interfaces. Okay, this is what I told you, and yet I'm doing that here. I'm checking if another object is an instance of a string history, and by doing so, I'm losing some. Okay, if I had another implementation of string history, which was another string history, which also behaved the same way, had the same interface, I would say no. They're not equals, even though they both implement the same interface. Okay, so there I'm being bad, and I'm not being very general. Okay, I'm not being that polymorphic, okay, because I'm restricting the type of objects that I really work with. But I showed you this, I did this here to show you a feature of Java. So there's always an issue, when can you access the instance variables of a class? Okay. So if you invoke a method on an object, then that method can access all instance variables of the class of the object. Okay, so the object on which you invoke a method, okay, when you invoke a method on an object, the method can look at all the instance variables of the class of the object. Okay, you've seen that. Okay, element add can look at contents because it's invoked on an instance of string history, and a string history, the class has the contents method. Here's something interesting. This equals can not only look at the contents of the object on which it was invoked, but this equals can look at the contents of an object passed to it as a parameter. Okay, that's interesting here. That I'm saying other string history dot contents. Even though this equals is being not invoked on this other string history, it's being invoked on the one I'm comparing it with, on this. So I can not only look at this dot contents, I can also look at other string history dot contents. Okay, and I can do that because other string history is defined, well, it's defined here. I mean, all other string history is a variable, and so I'm not sure what you mean by other history. Other string history is a variable, local variable, yes, of this method. But if this was other Cartesian point, if this was a variable saying Cartesian point, then I could not look at Cartesian points x and y coordinates, even though other Cartesian point is a variable declared in the method. So Cartesian points x and y I can't look at, but string history's Cartesian contents I can look at, because what's the difference between Cartesian point and string history for this case? We are invoking equals on, when we invoke equals, we are in a class that is the same as the class of the other object. Okay? So we are in a string history right now. Because we are in a string history, we can look at any object that is established to be a string history in this class. Okay, so this we know is an instance of a string history. We can look at that content. And other string history is also been established to be a string history. Okay, equals is defined as in a string history. So contents is visible here. Whereas Cartesian point is another class, so we couldn't do it. But because we are in a string history, we can look at variables of any object that is established to be of that class. And we know this, the object on which equals is being invoked, is an instance of a string history. And we know that this other object is also an instance of a string history. So we can look at any variable that's declared in a string history, or that's accessible in a string history. Okay, so this is a subtle point. A lot of people use this feature. It's tricky programming. The way I've asked you to type things, you'll never do such programming. But in equals, sometimes you need to access instance variables that are not exposed by any public method to check if the contents are the same. And when you have to do that, sometimes you have to do things like this. Okay, but if you go the right public methods, you don't really need to check for a particular class. You check for interfaces. And when you check for interfaces, there are no variables in interfaces, so you can't make any assumptions about the variables of the objects. Okay. So contents is accessible, is declared in this class, is visible in this class, and we know that other string history and this are both instances of that class. Okay. Questions? Okay. So I'm just saying null. Yeah, I'm just explaining what instance of means here. We saw that later. So variables of this and other instances of a class visible in class. Okay, that's essentially what I just said. Okay, and when you say other object instance of a string history, other object could be a string database, other object could be a string set, but in all cases, it's an instance of not only the class of that object, but also supertypes of that object. Okay, but this is what. So here I'm saying what the problem with this implementation is. That if we had another implementation of string history, we could not use it for equals. It would say no, even though it would be right. So this is a limitation, and that limitation is overcome by doing this code, which is pretty much the code that we wrote in class. Okay, except that we've got the equals null check here, and now we're using the size method in other string history, not the size field, because we don't know what the class of string history is. And that class may not have a size variable. Okay, so we use the size method, and we can use it to compare arbitrary string histories. Example: a string history and a string set. Well, we could do that in the previous case also, but we could also use it to compare another string history. Okay, and here I'm accessing. Yeah.
Now, instantize, as you were saying, will give you if it's the class or maybe subclass.
Supertypes.
What kind of a how would you check to see if it is that class and only that class?
So I want to figure out if an object is an instance of a particular class, and so I want to check if the class of the object is a particular class. If you were inventing Java, what kind of method would you add? And some of you might have seen this. There's a get class method. And it has you can do equals. Equal. I think equals will work just fine. Okay, but equals method will certainly work. But I think equals will work fine, because it will only create one implementation, one object to represent the class. So the class itself is an object. If a class is an object, what is its class? Object is the superclass of all objects. Okay, how do we distinguish a vanilla object from an object that is a class? Class. So what's the class of class? Sorry? You have to stop the recursion at some point. Okay? And class is an instance of class. Funny thing. An object is an instance of itself. Okay, and in theory, it's tricky to figure out what that really means. In practice, it means that you can invoke all the methods in class that are implemented in class. Okay? So you can say get class, and there's only one instance of the object that represents a class. Okay? But you rarely have to do that check. Other questions? So here I'm using methods for everything. I'm using size for this also. So I'm not accessing the variable size. I'm calling size the method. I'm calling size the method here. I have to call size the method for other string history because we don't know what its class is. We don't know what its variables are. We know what its interface is, but not what its class is. But I'm using size here. And what would you recommend? To use the method size or to access the variable size? In general, what will be more efficient? Supposing my size method went through the whole array and counted all the non-null entries in it. Okay? So that method then would be, very expensive. So in that case, you don't ever do such a size method. Okay? But if you did, then the size method would be more expensive. The size variable is more, you have to type less, no parentheses, and it's more efficient also. Okay, so we had two choices. We could override or we could overload equals. Okay, our overriding of equals required all this instance of, use of instance of, and you look at instance of and say, oh, that's a pretty cool feature. And for now, we want to learn it, so I presented it. But if you're using a lot of instance of in your code, you're not doing very good programming. So I'm going to be banning by default the use of instance of, unless I say it's okay. And we'll see later why using instance of in most cases means that you're not programming well. Okay? So here we've got an equals that is overloaded, and we don't have to check for instance of, because that instance of check is implicitly done by declaring this to be of type string history. Okay? At compile time, we're not able to pass anything to it that is not a string history. So if we go and call equals with an object, with a Cartesian point on a string history, what's going to happen? Sorry? So this equals won't work, but the other one will work. There is an equals that's defined in class object. Okay, so we have two overloaded methods. Both equals are visible in this class. So when you call equals with something that's not an object, the object's equals is called, which will return false. Okay, so basically what we were doing implicitly there in the previous method is done. Okay, so this is much cleaner code, and you see why instance of is not a good thing to use. Okay, okay, so you understand the difference between overloading and overriding? So the signature is different. No need to use instance of. Was I?
Yes.
For what?
You were checking for each element.
Oh, I was checking for each element. Yes. Yes. Each string I was calling the equals. And in both implementations I did that.
So if you were overriding that method, is that still going to work inside it?
So I was calling equals. The top level equals is being called in a string history. The other equals is being called on a string. And guess what? A string also overrides the equals from class object. So it's equals in string equals in string history, and the equals in string history is calling the equals in string. Okay? They all call the same thing. So this is what, when I say in the assignment, please name methods, be consistent in the naming of methods. This is the kind of confusion that can occur, because there's this method here, and everywhere. So we have to figure out, depending on which object we're calling a method on, which equals we're referring to. Okay? Okay. So in class object, I have an equals that takes object as an argument. In class string history, I have an equals that takes also an object as a parameter. So I have overridden the equals in class object. Now I say string history equals new string set. Which equals that's going to be called? Yeah, got it.
The one from string history.
The one from string history because
It's overriding the.
it's a more specific one. Okay, it goes and says, string history. Let's go and figure out what its type is. Its type is the string history, and we're going to call an equals in that, and that equals overrides this one. So we're going to basically that supersedes the equals from class object. Okay, that's the whole point of overriding, that the more specific method is called. This is just like when we had a string set. When we did add element, the add element defined in a string set was called in a string set rather than the add element in a string database or a string history. Okay, that's the whole point of overriding. We call the more specific. Okay, so this is easy. Okay, now keep alert. All the other examples are very hard. Equals in more specific class joke. So that's good. So I have an equals in a string history. I have another equals in a string history. They're both in the same class. And we have now two overloaded methods in string history. I say stringset dot set dot equals a new string set. Which one's going to be called? There's no overriding here. There's overloading. See, when we saw overloading earlier, we said print line is overloaded. Okay, there's a print line for integers, there's a print line for doubles, and there's a print line for object. Never was it the case that the argument would match more than one print line. Okay, so there was no ambiguity. Based on the argument, you could figure out there's only one applicable. Now, you could pass a string set to either this equals or that equals. They're both legal. So, because that's what you want?
Well, I mean, I know it does that, because I've tried it, and it does the second. I'm not entirely sure of the It's just more, that's the type, use that type, and there's a type for the object, so it's more broad.
It's more job. So it's the same principle, that the more overriding. I mean, you had an equals that took object, that to which a string set could have been passed. You took the effort to write this equals. Why would you write this equals if this equals was going to be hidden by equals object? Okay, so that makes sense. And overriding resolution occurs at runtime. Okay, Java goes and says, oh, what is the object I have? Let me go up and see, whether let me go up the hierarchy and find the most specific method. Loading is resolved at, if one is resolved at runtime, the other must be, at compile time you'll get an error. At compile time, if you don't do things right, if you don't have an appropriate overloaded method, you'll get an error. And in this case, it decides at compile time that I'm going to call this equals. There are two different equals methods. And it says, look, I know they're both applicable, but this is the most specific class. I know this at compile time type, so I'm going to call the most specific one. So it's a very different mechanism, but the same principle, that the more specific thing wins over the more general thing. You had the more general thing, you took the effort to write the more specific thing, you must want it, so we'll give it to you also.
Now, if you have a class that extends the string, and it is overriding equals object method, and it has code for how that's supposed to be dealt with. You pass this type of a class, a dot equals method with a type that is string history. Is the overridden method going to take precedence, or the more specific method?
Okay, so you said a lot. How many of you understood what he said? Pretty good. I've got a bunch of slides later, which cover almost every case, including the case you just said. Okay, but if I didn't, please ask the question again. So equals with more specific parameter types chosen. Yeah, Preeti?
So writing an overload method in a string history, because both those methods define the same, do essentially the same thing for overload. They just take different parameters.
Oh, we don't know what these do. I put a dot there. They could be doing anything.
Okay.
They could be tossing a coin and saying, yeah, I feel in the mood to say yes now, and I feel in the mood to say no right now. Okay? But if they do the same thing, it doesn't matter.
Okay.
It matters only when they don't do the same thing. Okay? So this is being chosen at compile time by a different mechanism. Okay? Okay. I have equals in a string set, and that takes the more generic type. Okay, so this is Collins, is this your question? So I have a string set with equals, and the string set is the more specific class, and I have a string history with an equals that takes the more specific parameter type. Okay, so the more general class takes the more specific parameter type. Okay, and I say string set dot equals no newer string set. Okay, what do you think should be called? Which equals?
It'll call the equals in string set.
It should call the equals in string set.
Because
You're pretty confident there.
yeah, you would have to call the soup, you would have to call the soup method. You have to invoke the method in the superclass specifically in order that to
So you should say no, but string set is some variable somewhere else. It's not in any of these classes. So you said string set dot equals new string set.
Well, doesn't string set extend string history?
A string set extends, but this code might exist in the main. This code may exist in main. I mean, it's just being called. So you're saying string set dot equals new string set. Okay, and the more general class has a specific parameter. The more specific class has a more general parameter. It's confusing. I mean, what do you guys want here? Forget what Java does.
It would probably still go to the one that really kind of string history, which is more specific, and it has access to all of those methods. So it's going to do the same thing as previous.
So you're saying the parameter type wins rather than the class in which the method is defined. Anybody want to have a contrary opinion? Well, you had a contrary opinion. So I don't know what should be. I mean, this is crazy code, right? But just remember there are two mechanisms at work here. One is the compiler, and one is the runtime. Okay? The compiler comes first. So the compiler at this point says, what are the various equals that are visible here? And it collects all the methods that are visible. And then it forgets where these methods came from. It doesn't matter whether they came from class object to class string set, and says, now let me go and choose the most specific parameter type. So at compile time, the decision is made to call this equals. Okay? So because the compiler comes first, you win. Okay? Exactly what you said. And but it is confusing. Okay? So let's see. Equals with more specific parameter type chosen, even if it is in less specific class. Okay, and try it out. And I think this is how it works. Okay, I reasoned it out because the way I think compilers implement it, and I must have checked it out also at some time. But Java is this ever-changing language, so who knows what they might decide later. But unless the compilers change drastically, this is how it works. Okay, and this is just a cleaner way to write compilers. Based on what I just said, will you get different answers depending on whether you overload the method or override it? So you're going to do the same thing. Okay? And in a class string history, you might either define an equals with class that takes object as a parameter, or in string history, you might take equals with string history as a parameter. Can you write a program in which it would make a difference whether whether equals was overloaded or overwritten? Masha?
So it doesn't matter if you can
If you? Okay.
But if you have a parent class that overloads it and a subclass of that class that overrides it, then the override is going to say equals to object. And so it won't actually be called. The parent class can actually be called.
So you have class A, B, and C, right? Class A has class A is object, okay? Class B has equals as
Class B overload.
Yeah, what a quaint idea, right? Okay, so you have class A with equals. Now you see how bad my handwriting is. Okay. Class B is equals. Hang on. Okay, so let's say small c is an instance of class C. And now you say C equals new or string history. Okay? It's going to call the equals of? Right. But if you did string history, if you had this string history also, then it would call this. That's good. Supposing you just have our example here, just two classes. Would it still make a difference? Can you make a difference here? So we had to have three classes, yeah.
Well, in the example, if the more specific method than the subclass, then they call the superclass method, which is not what we want to do.
Right, right. But in case we only have object and string history, so that's what Marshall was saying. Right. Okay. Just with two classes, could you make it behave differently? Think of casting. So when you use casting, let's just see the example here. So can the behavior be different if you overload object equals instead of override in this particular case, in a string history case? Okay. So I have string set 1, that's a string set. String set 2, which is also a string set. Okay, and we have only two equals here. We don't have three equals. String set 1 dot equals string set 2. Okay. And you say string set 1 dot equals object string set 2. Which equals is going to be called? Objects. But had we overridden equals in a string history, which equals would have been called? String history. Okay. So because we overload, when we override, we just hide that equals from object. Whereas when we overload it, we don't hide it. And it's still accessible, so it's going to return actually false. Okay. So this one shows you the behavior when we actually override it, when we override it, this is what, when we overload it, this is what we get. Okay, when we override it, we'd get true. Okay? Yeah.
I know there's specific rules for casting in terms of class hierarchy. Can you cast up and not cast down?
You can cast down and up. As long as, supposing you're in type T2, the type of the object at compile time is known to be type T. Okay? You can cast to either type T1, where T1 is a T, or a type T1 where T is a T. Either way. Because you can assign, the more general type may actually have a more specific object assigned. So if it is plausible for that type to have an object assigned, for that variable to have an object assigned of the appropriate casting type, then it will allow. So you can cast string set to string history and string history to string set, but you can't cast string history to Cartesian point. Never will a variable be allowed to have hold of that. Okay, again, overloading is resolved at. Okay, just when you think you understood things. I have two equals methods. They can be in the same class. Okay, and the word the equals is the wrong word here. I mean, some method. Okay, I'm still calling it equals. Well, actually, this equals, let's say, is not checking this versus the other object. It's checking these two objects. Okay, so this is a different kind of equals. And in the first parameter is string history. The second parameter is object in the first case. And in the second case, the first parameter is object, and the second parameter is string history. And I say equals string set, string set.
Is it fair to say that you can call it status method? But you're really not calling it against an object. You're calling it and you're passing it both objects. And you're wanting it to do something with it too.
Yes. So a static method is something I might get into. I mean, I kind of expect that you guys to know this from the previous classes, but I know from talking to you guys that you don't quite understand static. But you're right, and this could be, right now I have not said anything dot equal, so this is like a static method. Okay? In fact, this could very well work with static methods. Static methods are methods that cannot be overridden. So if I was to show you overriding things, I wouldn't be able to use them, but here I'm using overloading. So yes, it's fair to say that this would be a static method, and I should really, and you kind of see that because I don't have any object here. Okay? Which equals should be called? So you go left to right, and you say, okay, the most specific left parameter is the one you choose. You could go right to left too, right? But then we tend to be left to right. In the English language is left to right. A lot of languages are left to right. Anybody have another theory? You see that there's ambiguity. In that the left parameter is more specific in the first method. The right parameter is more specific in the bottom. Okay, which one should we choose? How many of you like this explanation? By the way, what's your name? John? Don? Sean. That's not close enough. I'm not that bad. Okay. You like Sean's explanation? Yeah? Yeah? So it's confusing. Yeah.
Could it use the one in the more specific?
They're both in the same class. That's the problem. If you have static methods, the overriding doesn't happen specific. Inheritance just works very funny there. Yeah. Sorry? Okay, that's what you should really do, right? I mean, this is bad programming. This is confusing programming. Remember that you don't want to write programs that confuse you. There was a time when people wrote very small programs that the challenge was to write confusing programs, to write, tricky programs. And there was a language called APL. You heard of read-only memory? And we often talk of journals that are write-only, that nobody ever reads those papers, you only just publish in them. APL programs are write-only. You wrote them, if you got it right, you're happy. 2 days later, you don't know what the program does, and never will any reader know what the program does. Okay? So you can really confuse the hell out of people if you want to. I mean, you write English that's confusing, right? You can have long sentences like Hemingway does. You just go and semicolons and commas, and then you see a full stop, and 10 pages later. So you can always do such things, and nobody knows what's going on. Or you can write very simple code. So you don't want to go. I mean, trust me. You make enough errors writing simple code. They don't want to write code that's obscure. So this is ambiguous. I mean, you can use the left to right rule, and language designers have really struggled with this. So supposing you have import package1.class C, then you say import package2.class C. So you've got class C from two different imports. What happens in Java if you do that, by the way? You say import project1.Cartesian point, import project2.Cartesian point. Anybody tried that? It could use the first one, up to down, left to right. Some languages did that, but it's confusing. I mean, the import, you don't even put imports nowadays in Eclipse. Eclipse just puts the imports for you. You don't know which order it went into. So to require you to know the order and rely on the order is very confusing. Okay, so language designers have struggled with this. Should we allow multiple inheritance? Should we not allow multiple inheritance? Should we allow super.super? Should we not allow super.super? And there's a consensus that don't confuse more than is necessary. Just define a more specific equals. So when you declare these two equals, the compiler will not complain. If you create an equals object, another equals object in the same class, Java will say, hey, I'll never be able to figure out which equals should be called because the parameter types are identical. Here the parameter types are different. So Java at compile time will say fine. But at runtime, when you go and say equal string set, you string set, you said in this instance, I can't make up my mind. I don't want to use some confusing semantics. So go change your program. Okay? And this is how you should change your program. You should have a string history, and then we know which one is to be called. Okay?
What would be the error when that line is?
It will say ambiguous. There'll be some compile time error saying can't resolve.
Compile time?
It'll be compile time. Overload resolution occurs at compile time.
I think that it was
No, compile time. When you declare those two equals, there's no problem. When you use it in some other piece of code, at usage time, at compile time, it will say, sorry, I can't figure out. Okay? Because it knows what types are here. Okay? Either there's a variable here which is declared to be a certain type, or you've got an object whose type is a parent. Okay? Okay. Questions? You still haven't finished equals. You guys like the fact that null is an instance of everything? Okay, this is what the price you pay now. Or it should happen. Call this one. So it pretty much does that. So null is an instance of everything. Null is an instance of a string's history. Okay, so let's go and put the most specific interpretation of null and then call the most specific method. Okay? This one. So what if I really wanted this particular equals to be called? Yeah. Could you cast null? Yes, you can cast null. I think I have an example. Okay, so now tell me, guys. It's ambiguous again. Good. Okay. So this is legal, and I got the right equals I wanted. Now, by the way, would you ever write such code?
Hopefully not. Well, in the event you had some variable that you hadn't, you assigned it to null, and later on you go ahead and change it to the other thing. It's plausible you could come up with a scenario like this, because the first time you loop through, you have some sort of transpose problem, and you need to have it do this the first time through and never again. But you wouldn't intentionally write code that just did this once and then went on to the next.
So you would never write such code.
It's possible. I would never intentionally cast the statement no. I may end up casting a variable that is defined as no.
Object editor is full of such code. Now you know why you got all the exceptions, right? So why are you casting now? So often some parameters are optional. Okay, so you go and just have a lot of parameters and some are optional, and when you don't want that parameter, when you're making no decision about that parameter, you just pass a null value. Okay? So I might have overloaded methods that have optional parameters that differ only in the parameters that, whose values are null. So at that point, I choose this overloaded method or that overloaded method based on how I cast the null. Okay? So, as you write more code, you might find use for doing so. I found out these semantics by programming this stuff. This is not just theory. So you do sometimes write such code, okay, but try not to. Okay, so null parameter often pass on optional values, and you may want to decide how to do it. Okay, we understand overloading, overriding really well. Okay, better than you might have wanted to understand it. So the question is, should we override, should we overload? And we saw that, we get different answers based on, what we do. And the behavior can be different if we overload object equals instead of override. So supposing we really want to overwrite, okay, and we are in some class B, and we don't remember what was in C, B, and A, but we want to make sure we are overriding a method we are inheriting somewhere, C, B, and A, and we don't want to go look up those methods. Is there a way to have Java check that we are overriding?
You add the at override anything to
Okay.
that other.
So supposing I really want to override, and I accidentally do this. So supposing we really override, we can accidentally create overloaded rather than overriding method. Okay, if we're really doing override, because we don't remember what the type was. And I can do this.
You learn the trouble if you had that essay from your interface. Because I know in Eclipse it has a green triangle opposed to a white one, but neither will return an error if you wanted to override and you have a method in your
Interface.
It won't give you an error. It's just the triangle over to the side is going to be white opposed to green.
Oh, really? There's a green versus white triangle?
Yeah, green is overridden from some parent class. White is overridden from me.
Oh, I'm such a... these people who do ads don't win with me because I don't notice things. I don't even notice this thing there. So I was going to make this statement. So firstly, let's understand what this means. This is saying, this is an annotation. Some of you have used object editors, annotation facilities. And how would you define an annotation again? What's an annotation? So we have various things. We have expressions. So null is an expression, not a statement. We have declarations. So you have int I is a declaration. And we have statements. I is assigned the value 5. And we have comments. Okay? So we have these concepts, and we're adding annotations. So annotation is what? Is it a statement? Is it executed? Yeah.
It's a readable comment, so it reads it as comment, but it kind of implements it in the program.
So it's a structured comment, a comment with meaning in it. A comment normally is free form. Okay, and you can say whatever you want to, and Java doesn't know what you're talking about. Okay, there are actually some conventions on how you comment things. Java has these conventions, which I never kind of mastered. This is like a readable comment. It's not executed, but it's like an annotation. That's what it is. It's a directive. Okay, so it's an annotation. It's a typed comment that can be processed by some tools such as compiler, Eclipse, or object editor at compile or execution time. You can look at this at compile time, like override, or you can look at your annotations, which all access actually at runtime. The object editor goes and looks at this class, finds out what annotations there are, and does different things. Okay, so if you go in, this is like an assertion. We'll see what assertions mean later. But this is a form of assertion saying, I'm asserting that this method is an overridden method, and it will go and complain if that assertion is false. Okay? Now, supposing you're in a string history, and a string history implements the interface string history, and you say override element at. Okay, a string history's class is object. Object doesn't have the method element at. Yet, forget all these green and white triangles. Java will not really complain about this override. Okay? Eclipse won't and Java won't. Eclipse kind of complains, but Java certainly doesn't complain. It compiles. So that must mean that it doesn't. What you should really do here? So basically, saying here that if you put an override annotation for a method m in class C, it indicates that m is a re-implementation or implementation of some m declared in some type t where c is a t. So basically, that method has to be declared in some t, some other type t, where this class C in which you're putting this overriding implements that. Or where C is a t. So what you really should be doing, and by the way, you can always not annotate things, that's okay, but when you annotate, it checks that. What Java should really have had, and then we won't have to worry about these green triangles and white triangles, it should have said at implements, okay, which is saying this method is implemented in some interface. And we shouldn't have used the word override in a wrong way, okay? And apparently the Eclipse semantics are pointing out that the lack of such an annotation, at least it didn't exist at one time. It may exist right now. Java's, gradually cleaning up its act. So, but implement and overriding are bundled into one thing by that annotation. Exams for okay, because I really am not going in depth here. Okay, so there's a difference between overloading and overriding, and we can make sure that we're overriding by the annotation. Now, should we overload or override? And what do you guys think ultimately? We know there's a difference, but what would you do? And I kind of answered the question earlier in the class. Do you want to use instance of? I mean, that's just doing checking that compiler does for you. Okay, yes, you can come up with these situations where you get different semantics. With overriding, you definitely are able to hide that method. With overloading, you're not, but generally don't use instance of. Okay. Use instance of only if necessary, as it creates messy and difficult to extend code, and more on this later.
Now, most of the examples that Dottie method you were using, it was what Dottie method is used based on what the parameters are. If you are to take and you're to cast the actual object that you're passing the method to type, so in your example on the board, type C, B, or A, you type C to an A, is it only going to run the object method at
Okay.
that point?
So
Regardless of what the parameters are?
I can cast the parameter, or I can cast the object. Okay. And I'm going to talk about this in great depth. Okay. The short answer is, in Java, casting the object just doesn't make a difference. Okay, because it's done at runtime. Casting the parameter makes a difference at compile time. Okay, in C++, there were two kinds of methods: virtual methods and non-virtual methods. And in that case, the overriding was either resolved in one case at compile time and the other case at runtime. So casting made a difference. In Java, casting the object doesn't make a difference. And this is very counterintuitive to a lot of people. But as it turns out, it makes for much nicer, much more modular, much more sharing of code. Okay. So I'm saying that, yes, there's a difference, and based on whether you overload or override, but in general,